5.5, apply the remainder and the factor theorems. So for our first example, we're going to use a long division to divide, and we're going to divide f of x equals x cubed plus 3x squared minus 7 by x squared minus x minus 2. So we're used to doing long division with numbers, but now we're going to do it with polynomials as well. So the part that I start with, I'm dividing this one by this one. So that means the x cubed plus 3x squared minus 7 goes here. And then my divisor, my x squared minus x minus 2 will go outside. So I'm really looking at x squared dividing into x cubed. That's what I really want to look at. And sometimes it almost helps to think about it in terms of multiplication instead and think, well, if I already have x squared, what would I have to multiply by to get x cubed? And that's going to be x. So we're going to write it on top, just like we would with regular long division. And just like with regular long division, we're going to take the x and multiply by x squared minus x minus 2 and write it underneath. So x times x squared would be x cubed. X times minus x is minus x squared. And then x times negative 2 would be negative 2x. So you can see that this 7 doesn't really go with the x. I think I'm going to go ahead right now, and I'm going to write plus 0x and then minus 7. Because I really want to have the x squared x, the x cubed x squared x, and then that constant term as well. So it really goes in descending order. So after we multiply it back, in long division, we always subtract. But I have to subtract this entire polynomial. So I'm subtracting this one, but then I'm going to be adding the x squared, and I'm going to be adding the 2x. Because we have to subtract this entire thing, we have to distribute that subtraction. And after we do that, we can just add, right? We're adding x cubed plus negative x cubed, 3x squared plus x squared. We know these two are going to cancel. So we have a 4x squared and a 2x. And now we're going to bring down that minus 7. So these steps should seem very familiar, kind of like what we would do with regular long division. So now I have to figure out x squared into 4x squared. What would that be? So again, I find that multiplication helps me. So I need to think about how if I have x squared, if I want to multiply by 4, then I would get 4x squared. And since it's a positive 4, I'm going to write plus 4. And then we're going to multiply it back again. So let's see, 4x squared minus 4x minus 8. And then remember again, we're subtracting this entire polynomial. So I need to change my sign. So I'm subtracting this one. When I distribute the subtraction over here, now I'm adding. And same thing with the 8. And then I'll put them together. And I have, let's see, 2x and 4x is 6x. Negative 7 and 8 is a plus 1. So this is going to be my remainder out here. So my answer is the x plus 4. And then my remainder is the 6x plus 1, and I can make a fraction out of that with my x squared minus x minus 2. So that's going to be my answer. And then I also always like to write down and remember. And I'm just going to kind of show this as a multiplication problem. I think I'm going to write remainder off on the other side so I have space. I do think it's good, though, to label it as remainder. And this one up here is our quotient. So what we need to remember is if I take that x plus 4 and I multiply it back by the x squared minus x minus 2, and then I add my remainder, that's going to equal my function I started out with, x cubed plus 3x squared minus 7. So some years when we have time, we actually kind of go back through and show that, just to show how that, it's really thinking through what that long division means in terms of polynomials. So we're going to try a simpler one. This time we're only dividing by x plus 3. So I'm going to put the x plus 3 out here, and then inside 3x cubed. We're dividing by something that's more simple, but because we're only dividing by an x plus 3, it's going to take more steps. So let's see, again, x, and we have to think about what would we multiply by to get 3x cubed? That would be a 3x squared. And then we take the 3x squared, we multiply it back by x plus 3. So 3x squared times x is 3x cubed. 3x squared times 3 is a 9x squared. And now remember, we are subtracting this whole thing. So if I'm subtracting this whole thing, I'm really subtracting the 3x cubed, and I'm subtracting the 9x squared. So when we do that, we will have, let's see, 17 minus 9 would be an 8x squared. And because I have two terms over here with the x plus 3, I'm going to bring down the 21x so that I have two terms. And now I have to divide x into the 8x squared. So we would need to multiply it by an 8x, multiply it back, 8x squared plus 24x. And remember again that we are subtracting. And then we got them all lined up. Let's see. 8x squared is gone. 21x minus 24x would be a minus 3x. Bring down the minus 11. And now let's think. X times a negative 3 would give us a negative 3x. Then we multiply it back. Negative 3 times x, negative 3x. Negative 3 times 3 is minus 9. But again, we have to subtract. And so that would give us a negative 2. So our answer is that we get 3x squared plus 8x minus 3. And then I'm going to write it as plus negative 2 over x plus 3. So now we're going to look at a different kind of division. It's called synthetic division. And when I think of the word synthetic, I think of the word fake. Like made in a lab, fake division. And that's kind of what we're doing. But synthetic division does provide the quotient and remainder. Let's say provides the quotient and remainder when a polynomial is divided by a binomial. So it only works when we're dividing by a binomial. So for example 1, we couldn't have used this anyway, but it could have worked for example 2. So we are going to actually revisit example 2. And I know there's not a lot of space here, but we're going to do it anyway. And we divided by x plus 3. So let's say x plus 3 equals 0. So that means we're looking for x equals negative 3. So we are going to evaluate f of negative 3 using synthetic or fake division. And I love to watch your faces as we do this, and I'm really disappointed that we're doing this as a video lesson and I won't get to see you guys, or even a Zoom lesson. I won't get to see how cool it is. So what I do is I'm going to use negative 3, and I'm going to put this little box around it. And there's different ways of showing the work for this. Different textbooks show different methods. I could not even tell you which textbook method I'm using at this point. Then I write down my coefficients, 3, 17, 21, and 11, and I write them down in order. And it's really important that they are exactly in descending order. And if I have any zeros, that I fill it in with a 0. Like if I was missing my x squared, I couldn't just write down the 3 and then the 21. I would have to put a 0 for the x squared. I'd have a placeholder there. So I have cubed, squared, x, and constant. Now I'm going to draw a line underneath this. And again, lots of different ways to show the work. I am going to bring down this first number below the line. So I'm going to bring down the 3. And then we are going to multiply and right over here. So 3 times negative 3 is a negative 9. I put it underneath, and then I'm going to add 17 and negative 9 is 8. Then I'm going to multiply it again. 8 times negative 3 is negative 24. And then I'm going to add, I get negative 3. Let's see, negative 3 times negative 3 is a positive 9. And then I add and I get a negative 2. So this is the really cool part. When I look at what I just came up with, the 3 and the 8 and the negative 3 and the negative 2, you can see that those correspond to these numbers up above. Here's my 3, my 8, my negative 3, and my negative 2. So because I started out with cubic, this is now my squared and my squared and my x and my constant, and this is my remainder. So these are my coefficients of the quotient. And the last one's my remainder. So we could get those same numbers just by doing this little fake division trick. So we're going to look at this some more. So let's go on to the next page. We are using synthetic again. It says x minus 3. So remember, it means we're actually going to be using the opposite. So we're going to be using x equals 3. So I'm going to put a 3 right here. My coefficients are 2, 9, 14, and 5. And I'm just checking cubed, squared, x constant, so they're in descending order. Draw my line. I'm going to switch mark colors again. So we always bring down the first one. So we're bringing this one down. And then we multiply. So 2 times 3 is 6. And then we add. It's going to be 15. And then we multiply again. Let's see, 3 times 15 is 45. And then we add again. Let's see, 59. And then 3 times 59, let's see. So that would be 60 times 3 would be 180, but it'll be 3 less than that. So 177. And then we'll add again, 182. And so if we started out with cubed, then this is going to be x squared. So it decreases your power by 1. So our answer will be 2x squared. And then the next term will be x. And then the next term will be a constant. And then the 182 will be our remainder. So 182 over x minus 3. So remember, we're always multiplying. And then we write it over here. And then we add. Multiply. Lots of notes here. All right, example 4. So you can see now we're talking about factoring. And we're factoring something. It has 4 terms. It starts with x cubed. I can't do factor by grouping. I can already tell. Like if I look at the 2x cubed and the 11x squared, I could factor out an x squared. I'm left with a 2 and an 11. Here, I could factor out a 3. I'm left with an x and a 12. So factor by grouping is not going to work. So as we get into these larger powered polynomials beyond quadratics, we need other tricks. So they're telling us that x minus 3 is a factor. So what that means is I'm going to use synthetic, and I am going to figure out what's left when I divide by x minus 3. And then I'll be able to take that resulting polynomial, and I'll be able to keep factoring it. So let's see how that works. So I'm going to put a 3 here, because remember, if it says x minus 3, I use a positive 3. My coefficients are 2, negative 11, 3, and 36. And maybe we'll even put our steps over here. So our steps first are going to be, let's scroll back. Use synthetic. I don't know why that keeps popping up. Use synthetic. I must be bumping it. So we're doing that. So we're going to, again, bring down our 2. You don't have to draw these little lines. I'm just doing it to try to help you right now. If it's confusing, don't do it. 2 times 3 is 6. Write it underneath. Add negative 5. Negative 5 times 3 is negative 15. Add, I get a negative 12. 3 times negative 12 is 36, and I get a 0. So this 0 is really important. This 0 means yes, x minus 3 is a factor. because it divides evenly and there is no remainder. And we'll look at that theorem in a second. So we use synthetic. Now we are going to write our depressed equation. And we're going to call it a depressed equation because instead of being third power, since I divided by x minus 3 by putting a 3 up here, now this one that I have left, remember if we start with cubed, this starts with squared now. So my coefficients, my 2, my negative 5, and my negative 12 are going to be a 2x squared and a minus 5x and a minus 12. So this is my depressed equation. And remember, I'm trying to factor this now. So now I am going to come up with two binomials. I know I have to have 2x and x. And then we want to think about how to get a 12. So I'm going to guess it's not 2 times 6 for 12. Those would both be even. 1 times 12, probably not. I'm going to try 3 times 4. So if I do the 2 times the 4, and that gives me a negative 8, and then I add a 3x, that will work. So I've continued factoring. So now I can factor my whole thing. So remember, f of x equals 2x cubed minus 11x squared plus 3x plus 6. And now we can factor this entire thing. We know that our first factor was at x minus 3. And then that's what led us to this one right here, that depressed equation. And then we were able to factor the rest. 2x plus 3 times x minus 4. So all of that together would equal our original polynomial. So let's kind of go through and make sure we didn't leave out any steps. We used synthetic. We wrote the depressed equation. 3 was to factor the depressed equation. And then 4 was to write the complete factorization, I guess you could say. And this is the word factor up here. I know it doesn't look like it. My handwriting got pretty messy there for a second. So the two theorems we've really used, but we didn't write out, that I think would be worth going over are Remainder Theorem. And my pen has suddenly quit writing, and it does that sometimes until I scribble, and I don't know why. Maybe it's because this is outside my margin. Let's erase, and then we'll see if we can go back and fix it. Now it's writing. The Remainder Theorem. So we used the Remainder Theorem when we had when we were dividing. So if a polynomial f of x is divided by x minus k, then the remainder is r equals f of k. So notice here it says x minus k, all right? And then over here it says f of k. So that's like where we switched the signs, all right? So I'm just going to scroll back up really quick and then hope the pen works again. So that's like where here I had that x minus 3, but I divided by 3 instead when I did my synthetic, my fake division. So that's what the remainder theorem tells us. And the other important theorem that we used today actually was called the factor theorem. And now the pen's working just fine. I think sometimes I just write too much and I'm too fast and it needs to catch up. Factor theorem is a polynomial f of x has a factor x minus k if and only if I know that sounds like geometry language now. F of k equals 0. So the really important stuff here is if I divide by x minus k, but when I evaluate that using my synthetic, I get a 0 at the end. Remember that 0 we pointed out? That 0 meant that it divided evenly, and x minus 3 was a factor. There was no remainder. So basically we're saying if there's no remainder, if the remainder is 0, then it must be a factor. Right? The x minus k is a factor after all. So these are the two important theorems that we use today, but we just did not spell out in our notes. Normally you'd have a book, we could refer to them in there, but we don't have it. So I think it's good for us to go ahead and write them down. So as always, make sure you ask questions in class, and I hope you have a great day.